We have studied the measurement of information, and in the next, we will discuss the algorithm that using decision trees to make predictions about the target value and how decision trees are linked to information theory, which prepares us for the next study of decision tree building algorithms. Decision tree building algorithms. Now let's consider how decision tree works. Consider a sample problem of deciding whether yourself or if you are a manager of a sport facility, one of your customers is going to do the workout today. It depends on four factors, basically about the weather, how the outlook is. Is it sunny, overcast, raining? The temperature, humidity, and the wind. A typical decision-making process, not surprisingly, would go like this. Let's have first look at the outlook. If it's sunny, yes, we do the sport. If it's overcast, yes, we do the sport. If it's raining, well, let's consider the temperature, and we make our decisions accordingly. Obviously, we haven't considered the factors of wind and humidity in this decision procedure. You are not forced to use all of the factors or the attributes of the weather. This is another decision tree. It's also about sport. Now look, when this customer or maybe this process is not as sporty as that one, when the outlook is sunny, then the next consideration would be humidity. Or if you put it very simple, you can have such a decision tree. Although it is trivial, it is a decision process. It's very sporty. Whatever, I go to sport. Sorry. Considering all this decision-making process and put that in the big picture of machine learning, this picture, the data algorithm, loss and hypothesis space, what we were discussing, the decision trees, is here. We consider a family of hypotheses, and this hypothesis compares or checks the observed attributes, the X, the data, using a set of conditions, and one by one individually. And if the condition is passed the test, it then looks at different depending on whether the test has been passed, it looks at another attribute and test that use another condition. So that's the decision tree. Simple enough. Okay, and how that works with data. Because that is the hypothesis family, and we know the task of learning does not stop there. We need to select one particular hypothesis that we will use in future, and the selection is with respect to how that hypothesis perform on the available data. Say if you are a manager of a sport club, you may have a historical record of some customer. In your record, you have the decision whether the customer comes or the customer did not do the sport in different weather conditions. And you want to build the decision procedure like what we discussed above automatically. In the next, we will look at how this challenge of building such a decision procedure linked to what we have discussed about the measurement of information. And then in the next video clip, we'll discuss the specific the algorithms. So decision tree building and information measurement. If we recall what we have done in asking clever questions to remove uncertainty in a system, we will have something like this. The first question is the marble blue? And by using this question, we have split the system into two parts. And one part is pure, is certain. The information contained in this half is zero, is a certain system, and all the uncertainty is in this part. If you compute the weighted entropy of these two subsystems, it will be less than the entropy of the total system. And the cost, of course, is the 1 bit of information of answering the question. Or put it another way, the 1 bit you need to transmit so to communicate the status of the system at this stage. Using the next question, we further split the second half of the system into two halves. And now this part has entropy 0 as well because it's certain, and all the uncertainty is in this. The weighted sum of the subsystem is further reduced. Until lastly, after we have paid the price of 3 bits of information, every subsystem is certain, and all those subsystems has an entropy of 0. The sum of their entropy is 0. And the entropy had been embodied in the 3 bits we have used to answer the question or transmit the status. You may find some kind of similarity, a link between this process and the decision-making process of whether to take the sport or not. Let's come back to the data. So I deliberately color the data using the colors we have used in our marbles. Now we have those no answers and these yes answers with respect to whether to go to report sport. And I have a try. The difference is, of course, when you build a decision tree, you do not have the luxury of directly asking, is the target value yes or no? Because if you do that, this system won't work in practice. What you can do is you can ask questions not directly about target value, but about those observable value here. So to build a link, I sort the table with respect to value of this attribute, the outlook. If I sort this, well, you can see if the outlook is overcast or rain, the customer goes to sport. Oh yes. And if we split the system, at least the system as represented by the observed data in this way, well, we ask if the outlook overcast or rain, and if the answer is yes, then all uncertainty about whether to go to sport disappears. This becomes a certain system, and we arrived at our prediction will go to sport. On the other hand, if the outlook looks sunny, we may need, in this, the later subsystem, we will need to consider other attributes to decide whether to go to sport. To further reduce the uncertainty in this first level subsystem into several second level subsystems to reach certainty. So we will discuss the training of the decision tree building algorithm in the next